Okay, number 1. If the two triangles are similar, what is the length of the missing side? All right, this should be easy by now. This side corresponds to this side. So the blue side of the small triangle, we're going to compare to the blue side of the big triangle. And we want to find this missing side, so I'm going to choose this side, or I guess I have to. The bottom side of the small, we'll call it the red side of the small and the red side of the big. That could be better, but let's move along. The red side of the small triangle to the red side of the big triangle. Is this a valid proportion? Well, we're comparing the same features on each side. The blue sides to red sides, or blue sides on the left, red sides on the right, small triangles on top, large triangles on the bottom. Valid proportion, let's fill in our numbers. So, I'm going to skip a step here. We're going to just convert these mixed numbers into improper fractions. So the blue side of the small triangle is 10 times 2 is 20, plus 20, or 1 plus is 21 over 10. And we're going to put that over the blue side of the big triangle. 5 times 4 is 20, plus 1 is 21, and that's over 5. Who can guess what this is going to be? And then the red side of the small triangle, which is 3 1/2, which is 2 times 3 is 6, plus 1 is 7 halves. And that we're going to put over, we don't know, some unknown quantity we'll call x. So all we do is multiply and then divide. 7 halves times 21 over 5 equals something over 10. 21 times 7 is going to be 147. 147. And then 147 over 10 divided by 21 over 10, or times 10 over 21, equals, that's going to be 1,470 over, and 21 times 10 is 210. And now let's simplify that. Let's make that into a mixed number. 1,470, 1,470 divided by 210. 210 goes into 1470 exactly 7 times. Look at that. Nice, pretty number. 7 times. Is 7 one of our answers? Yes. So this side is 7. See, and who can tell me the scale factor between the big triangle and the small triangle? If you said 2, or 1 to 2, this is 1 to 2. Or you can think of it as 2 to 1. All of these numbers are twice these numbers right over here. What's 3 1/2 times 2? 7. 2 4/5 times 2? 3 3/5. 2 1/10 times 2 is going to be 4, and actually, and 1/5, or 2/10. So, off we go. Okay, number 2. The ratio between the length and the width of the rectangle below is 7 to 3. What is its area? That's the question. Keep that in mind. What is its area? So, as soon as you hear area, you should write down area of a rectangle equals length times width. And we know the length is 4 1/4, which is a 17 over 4 times and an unknown width. So, what are we comparing here when we set up our proportion? We only have one rectangle, but we also have a ratio, which tells us the ratio between the length and the width. So if we compare length to width, should equal length to width of something else. We know that the ratio between the length and the width is 7 to 3, and that should equal the same, or that should be the same ratio as the length over the width of this rectangle. We know that the length is 17 over 4, and that's to an unknown width. Another way of thinking about this is if we know that the ratio of this rectangle is 7 to 3, then we know there's some other rectangle out there that also has a ratio 7 to 3, which means if its length is 7 and its width is 3, then this rectangle also has a ratio of 7 to 3. All right, you compare the length to the width of this rectangle, 7 to 3, over the length and width of this rectangle, 17 over 4, over an unknown width, that width. So now let's figure out what our width is. 17 over 4 times 3. 17 over 4 times 3 over 1 gives us 51 over 4. And then we divide that by 7, or we multiply it by 1 over 7, which gives us 51 over 28. Now, our width is 51 over 28, which is, if we turn that into a mixed number, 28 goes into 51 one time with a remainder of, let's see, that's 2 to 30, 30 that's 20, that's 1, that's 23 28ths. All right, and so our width, the width here equals 1 and 23 28ths. So, I'm guessing about half of you said A. And you would be wrong. That's not the answer. What's our answer? It asks us for what's our question? What is its area? We want to know the area. We know the length. We now know the width, which is, I'm going to use the mixed number, 51 over 28. All right, so now we can take our formula for area. Area equals length, which is 17 over 4, times the width, which is 51 over 28, 51 over 28, and that equals, let's see, 17 times 51, no, that's not right. 51 times 17 is 867 over 28 times 4, that's 80, what would that be, 80 plus 112. And then we turn that into a mixed number. 112 goes into 867 7 times and some change. And I don't even have to do anything right now because I know this is the right answer. It's 7 and something. And we know that it's not 1 and 2/28, it's not 2, it's not 9, but it's 7 and 83 and 1/12. And that's our right answer. That's our area. Moving on. Keon was just accepted into Carnegie Mellon University for computer science. He went on their website to check out what student housing is like. He found the following layout plan for a typical freshman dorm. What is the approximate area? Well, as many of you may have guessed, this is a composite figure, and you need to break it up into smaller figures. So what I'm going to do, you can do it anyway. There's plenty of ways to do this. You can, where's a bright red? That's not bright enough. Maybe, will that show up? No, that's not nice. Let's use a bright green then. How about that? All right. You can cut it this way and figure out the dimensions of these two rectangles. Or what I did, or what I would like to do, is I'm going to cut it this way. Now, that's not coming out at all. Let's use this. Cut it this way. And we know that instead of this being 2 inches, this is 1.8 inches, 1.8. And if this whole length was 2 inches and this is 1.8 inches, then what are we left with here? Just 0.2 inches. All right, so now we've got two rectangles, 1.8 inches by 2.3 inches. And that covers this big rectangle over here. And then we've got this small rectangle, 0.2 inches by 1.2 inches. Now, we don't want, notice all of the answers are in square feet. This is just a, not a schematic, but a blueprint, all right, where 1 inch equals 8 feet. Question, do we need to convert these numbers into feet before we multiply? Or does it not matter? If you think about this, let's take a 2 by 2 square, okay? Let's say it's 2 inches by 2 inches, all right? What's 2 inches by 2 inches? That'll give us 4 square inches, which if we convert from inches to feet, we multiply that by 8, and that'll give us 32 square feet, right? If we're using this this scale for this. This isn't a map, but this is a blueprint. All right, that's fine. So if we converted these figures into feet first, we should get the same result, right? And as you can see, we clearly don't. If these are no longer 2 inches, if we convert this into feet, if we have 2 inches, then this is 16 feet by 16 feet is definitely not 32 feet. That is, what is this, 16 times 16? All of a sudden, our answer now is 256 square feet. So, 256 does not equal 32 feet. 256 square feet does not equal 32 square feet. It's not even close. So do we have to convert these numbers to feet before we find the square feet, before we multiply? Absolutely. So if 1 inch equals 8 feet, then 1.8 inches equals how many feet in the real world? That is, in real life, that's 14.4 feet, just feet. And we're going to multiply that by 2.3 times 8. That's going to be 18.4. And so that this portion of the what is this of the freshman dorm is going to be, I can't even read my own handwriting. 14.4 times 18.4. So that portion is going to be 264.96 square feet. Now over here, let's convert this. 8 times 0.2 that's going to be 1.6 feet. 1.6 feet times, and then 1.2 inches in real life is going to be 9.6 feet. And that gives us 9.6 times 1.2 is 11.52 square feet. And so what I've done is I found the area of this big portion of the dorm and then this leftover portion of the dorm. So it's going to be 11.52 plus 264.96, and that gives us 276.48, or approximately 280 square feet. 8 times 0.2. Yep, that's right. Times 9.6. Oh, I did something wrong. I knew that looked weird. 1.2 times 8 is 9.6. 9.6 times 1.6. All right. Instead of 1152, this should be 1536, which gets you much closer to 280. But the answer is C either way. Number 4. Finance. On a recent day, 2 out of stocks in the New York Stock Exchange advanced in price. If 1,900 stocks were traded, how many advanced in price? Well, what are we comparing here? We're comparing stocks that advanced. Advanced to total traded, to traded. And so our proportion should look exactly like that. Advanced stocks that advanced means had gained in price to the total amount traded. Well, we know how many advanced in price. 2 out of 5 advanced, right? 2 advanced out of every 5 that were traded. How many advanced? We don't know. Out of how many traded? 1,900 stocks that day. So 1,900 times 2 divided by 5 is 760. So our answer is B. Number 5. It has been estimated that for every 10 volunteers working in a political campaign, the candidate gets 100 votes on election day. A candidate has 770 volunteers. How many votes can this candidate expect to get on election day? All right, what are we comparing? We're comparing volunteers to votes on election day. Let's say, well, they both start with V. Volunteers to votes equals volunteers to votes. I know this seems tedious, but remember what we did yesterday, this Wednesday. That worksheet where a lot of you were mixing up your numbers. and writing this out helped you a lot, especially on that deer question with the tagged and the non-tagged, or the deers in the forest. So, volunteers to votes. For every 10 volunteers, you get 100 votes. 10 volunteers, you get 100 votes. How many volunteers did the candidate have? 770. How many votes can they expect to get? 770 times 100 divided by 10 gets you 7,700 votes. Boom. Right there. Letter C. Okay, a rhinoceros beetle weighs 30 grams and can carry 850 times its body weight. That is 25,500 grams. If a person could carry proportionally as much as the rhinoceros beetle, how much could a 60-kilogram student carry? What are we comparing here? We're comparing weight to what do we compare to what you can carry? All right, weight to what you can carry. Weight to what you can carry. So what's the weight of the beetle? 30 grams. And the beetle can carry 25,500 grams. 25,500 grams. And that should equal the weight of a human or a person, 60 kilograms. Now, there's a problem here. All right, if you put 60 here, that's wrong, because you'd be putting 60 kilograms. What's wrong with that? Well, the beetle's weight is in grams. The human's weight is in kilograms. You can't do that. So how many grams is 60 kilograms? Well, if 1 kilogram equals 1,000 grams, then 60 kilograms is what? 60,000 grams. And then you can just solve for x. How much can a human carry? So that's 60,123,000 times 25,500 divided by 30 grams. And that gives us, 51 million grams. Now we have a problem. 51 million grams gives us how much in grams? We only have grams or kilograms. We've got 51,000 grams, 51,000 kilograms, and we know that those aren't the answers by now. So how do we convert grams into kilograms? We divide by 1,000. So 51 million divided by 1,000 gives us 51,000 kilograms. And so our answer is B. However, I did all of that, but some of you might have noticed, if a rhinoceros beetle weighs 30 grams and can carry 850 times its body weight, and a person can carry proportionally as much, and they weigh 60 kilograms, all right, if you know the weight of the beetle, how do you know how much the beetle can carry? 30 times 850. Doesn't matter about the units. It's 850 times its weight. That's 30 grams times 850 tells you how much the beetle can carry. In this case, in grams. So if the human weighs 60 kilograms, we know if it's proportional, then the human can weigh the same 850 times, which gets you 51,000 kilograms, which was another probably easier way of getting the same answer. Number 7. A pound of fertilizer covers 250 square feet. How many pounds are needed to fertilize a lawn measuring 70 by 50 feet? What are we comparing? We're comparing pounds of fertilizer. Well, let's use, I don't know if you guys know this. That's the abbreviation for pounds. LBS. Don't ask me why. I actually don't know. Pounds per square feet. So feet squared to pounds per square or to feet squared. That's what we're comparing. And we know 1 pound of fertilizer, that's the singular, 1 pound of fertilizer covers 250 square feet. We want to know how many pounds cover what? Well, 70 by 50, which is 70 by 50 should be 300, yeah, 3,500, 3,500 square feet. So what's x? X is 3,500 divided by 250 is 14. So how many pounds? 14 pounds. Answer is A. Letter B. Valentina is standing by a tree on a warm summer day. Her shadow is 5.5 feet long, while the tree shadow is 20 1/4 feet long. If Valentina is 61 inches tall, approximately how tall is the tree? You know what to do. You make lovely figures. Here's Valentina. She's standing by the tree, and her shadow is right here. All right, and then there's this nice little tree. All right, that's a weird tree. Let's put some roots and a little apple. And then we have a shadow for the tree. And we know that the sun is beating down in the same direction for both. And since we have similar triangles, then the ratio between the heights and the heights of the tree and Valentina and their shadows should be proportional, or the ratio should be the same. So now let's fill in our numbers. Valentina is 61 inches, and her shadow is all right. Most of you are going to do this anyway. Let's cheat and use decimals. Well, nah, okay, fine. 5.5 feet. And then the tree's shadow is 20.25 feet. We want to know what the height of the tree is. So what are we comparing? We're comparing height to length of shadow. Length of shadow equals height to length of shadow. All right, the height of Valentina is 61. Her shadow is 5.5 feet. And that should equal the height of the tree, which we don't know, over the length of the tree shadow, which is 20.25 feet. 20.25 times 61 divided by 5.5 gives you 224.59. And so how approximately tall is the tree? All right, we're working quickly because we want to get through this quickly. And so we circle D, 225 feet. And if you said that, you would be wrong. I'm sure most of you are disappointed right now. Why? Because what is the unit that we used for height? Valentina is 61 inches. Inches to feet, height in inches to feet. So this is 224.59 inches. Ooh. So how many feet is it? We divide that by 12 and we get the number 18.7, which is approximately, well, that's the wrong way to say it, or 18.7 is, 18.7 is approximately 19 feet. So the right answer is B. Now, was that a mean trick? Yes, it was. Does the MSA have questions that are specifically designed to trick you? Yes. Is it mean of them? That's for you to decide. But either way, we both have to deal with it. Let's go. Number 9. Put the following real numbers in order from least to greatest. Okay. We didn't go over this in class. This is a review and we will be doing it next week. However, if you're doing your homework and you're studying, then you can get an extra credit problem right. First thing I like to do is I like to take my negative number, and my negative numbers, and let's put those in order first. Why? Because as you know, negative numbers are tricky. All right, negative numbers, when they're going from low values to high values, the actual numbers go up. All right, -7 is less than -5, which is less than -1, which is less than 0. Do you see how you can easily get tricked here? All right, the numbers, all right, when they go up, all right, when they get greater, when you're increasing in value, the actual numbers themselves seem to go down. 7 down to 5, down to 1, down to 0 is actually up because this is on the negative side of the axis. All right, -7 up to -5, up to -1, up to 0. You owe someone $7 up, now you owe them less, $5. Now that you owe them only $1, now you owe them 0. You're on your way to making money. So let's put these in order. Which one is the greatest? I'm sorry, the least. All right, -5. All right, then we get -1/2. If you turn that into a decimal, that would be -0.5. Now, which is less, -0.5 or -0.51 or 51? Well, think about it. Would you rather owe someone 50 cents or 51 cents? Well, owing someone 51 cents is worse than just owing them 50 cents. So -0.5 or -1/2 is, I'm sorry, -0.51 is less than -1/2. All right, we've dealt with our negatives. Now we can deal with our positives. And the first thing you should do is you should turn your fractions into decimals. So 3/2 we know is 1.5, and 2/3 we know is 0.6 bar. Okay, now we need to compare all of these decimals, and I gave you decimals for a reason. The way I like to teach this is, I'm sure most of you know this intuitively, not intuitively, but from 4th or 5th grade when you first learned this, but some of you may still get tripped up. So I'm going to put all of these next to each other. 1.5, and then we're going to put a 0.2, and then let's put the ones that look similar next to each other, 0.02, and then what do we got? 0.5, and then 0.059. And what I like to do is, if this decimal has 3 places, then they should all have 3 places. So we can compare them. So which one is the greatest? Obviously 1.5, right? All right. Then what is the next greatest? Well, 0.2 seems to be the next greatest, right? Because obviously, if you have 2/10, that's more than if you have just some hundredths. And so now, what is the next greatest? 0.02 or 0.05? Well, if you have 5 hundredths, that's more than 2 hundredths, so that's going to be the next greatest. And then I know I'm going in opposite order here, well, actually, I'm sorry. 0.059, is that greater than 0.05? Well, think, if you had 5 cents, here you've got 5 cents and then 9 thousandths of a cent. So that is going to be the next greatest, and then comes 0.05, and then comes 0.02. So which one of these is the least? 0.02. So our next number after this is 0.02. The next number after that is going to be 0.05. Then slightly more than that is 0.059. And then more than that is 0.2. And then more than that is 1.5. And so this is all of those numbers in order, from least to greatest. We'll go over this next week. Hopefully most of you, I don't need to go into more detail here. But if I do, then either look this up on the internet tonight, or you just won't get this. You won't get this extra credit tomorrow, but you will get it next week on our quiz on Friday. So, moving on, the extra credit. The ratio of the radii of the 2 circles is 5:3. What is the area of the smaller circle? Ooh, so you have to find the radius of this smaller circle in order to find its area. Well, what are we comparing here? All right, radii of the, let's say, the big circle, yeah, it's 5:3, to radii, or the radius of the small circle, should be radius of the big circle and radius of the small circle. So we know that the proportion between the radius of the big to the small is 5:3. And we know that the actual radius of the big circle is 6.5 feet, and we don't know the radius of the small circle, but we can easily figure it out. 6.5 times 3, stupid calculator, 6.5 times 3 divided by 5 gives us 3.9. If r is 3.9, then what am I doing? I'm finding the area of the small circle, so the area of the small circle equals pi r squared, so that's 3.9 squared, which equals 3.9 times 3.9 times 3.14, and that equals an area of 47 approximately 76 square feet. And there's our answer right there. Oh, wrong color. I want a nicer color. 47.76 square feet. Now, the extra credit asks, is the ratio of the areas of the two circles above the same as the ratio of the radii? So what's the ratio of the radii? 5 to 3, right? What is the ratio of the areas of the two circles? So what are we comparing here? We're comparing, let's say, the radius of the big circle to the radius of the small circle should equal the area of the big circle over the area of the small circle. All right, so we know that the radius of the big circle is 6.5. The radius of the small circle is 3.9. The area of the big circle we didn't calculate yet, but we know the area of the small circle is 47.76 approximately. Now the area of the big circle is just pi r squared, so 6.5 squared times pi gives us approximately 132.67. Now, if these ratios are the same, then if we convert these two, the two sides of this expression into decimals, they should be the same decimal, right? Well, we know that 6.5 divided by 3.9 should be about 1.6. And we know this because we know the ratio is 5 to 3, and 5 divided by 3 is about 1.6. And so we should have the same thing here on the right side if their ratios are the same, if they're in proportion. So we do 132.67 divided by 47.76, and that gives us, 2.77. So their ratios are not the same. Is the ratio of the areas? Yeah, the ratios are not the same. And there we are. Don't worry too much about this last extra credit problem. It's there to challenge you. The other two extra credit problems are fairly simple. But even more importantly than that, all of these are ridiculously simple by now. Most of you were well equipped to approach the problems on Wednesday. And if you are still having trouble with number 1, go back and do it again and again and again and again until you feel comfortable with these fractions. You might even want to try solving it a different way. Instead of using the blue sides over the red sides, use, I don't know, call this a green side. Do this side. Use that one. So you just get practice with fractions. All right, here. The green side of the small triangle over the green side of the big triangle should equal the red side of the small triangle to the red side of the big triangle. Okay? Go. Try that. Get that right. You should get the same answer. And good luck on the quiz tomorrow.